Hello YouTube. Got another repair for you today. This time a HP. This is a nice 15-inch touchscreen HP Envy. And the model is 15 EUO 501 SA. So this has been sent in for a no power fault. The customer says it won't power on, the charge light lights up, power's getting to the chips on the board as tested with multimeter. Tried a different charger, RAM, and disconnecting the battery. So let's plug it in and see what it does. Let's get rid of that. And turn the bench supply on, see how much current it draws. Okay, not very much current. With absolutely no response to the power button. But it does recognize the charger to an extent. Oh, okay, yeah, we do have a charge light. Okay, it's charging this time. Or drawing 174 milliamps. Maybe it's not charging. 188. Yeah, it's bouncing around a little, but unless it's very, very flat, I don't think that's charging. So, definitely a no power fault. Okay, let's turn that off and see what's going on. Right, let's pull the battery. Just make sure there's no power in it whilst we're poking around. Let's have a look at what's going on. Let's go under the microscope and just have a glance over the board, see if we can spot anything. Visual inspection is always the first thing you want to do, so definitely worth just taking a look and seeing if anything's obvious. We're a bit dark. Hold on. Where's my microscope light gone? Okay, there we go. So we have the ISL here, which will be the charge IC. That looks fine. Some Realtek chip over here, which is probably for the card reader above it. Wi-Fi card looks okay. No signs of liquid so far. There's a lot of stickers on this covering. Whoa! What is that? This sticker's melted? Yeah, this sticker's melted. And there's a burn below it. Just on this fan. What? Has the fan shorted the system out? Just where it screws down to the board? I think I've seen this before. I think these systems do that, so that's probably the fault. The rest of the board looks good. Let's try and find a regulator that might have 12 volts on it. So this is a power supply of some sort. It'll probably have 12 volts coming in there. So let's check the resistance on 12 volts. 87 ohms to ground, so that's a partial short. I would think that would be about 400 ohms usually. So I wonder if that burn mark's got anything to do with it. I think that burn mark might be shorting out 12 volts or 19 volts or whatever the main power rail is on this system. Let's get the board out and take a closer look. I hate getting the boards out of these. The board's really big and the chassis is kind of tight. Do I leave the Wi-Fi screw in? Does that connect to the chassis? Yeah, it does. So remember to take the Wi-Fi out. Still very tight to remove this board. There we go. So it's stuck. There we go. Ah, yeah, it is stuck. It's stuck to that sticker, that. can actually see in the palm rest, it's melted the black sucker as well. That's been really hot. So, for those of you playing along at home, the board number is 203-037-T. And this is not the first one of these boards that I've seen blow a hole through that fan mount there. Now, I think 12 volts run through this area. Let's try and clean it up. So that's probably why our 12 volt, well, I keep saying 12 volts. So that's probably why our high side rail is bad. It's either going to be 12 or 19 on this system, but I think being a HP, it'll probably be 12. But yeah, that's that 88 ohm short, is all this burn area here. Hopefully it's not too severe, but it is a common problem on these. So the engineers must have made some mistakes putting 12 volts a little bit too close to the ground point just below the fan. So I guess the fan plastic rubs up against it, or some dirt gets in there or something, and it abrades the board a little bit. It rubs through the board and then creates a short circuit. Once that short circuit is there, it's just going to keep burning and burning. Yeah, see that copper's left in there. Okay, let's cut that off. Don't want that. So have a look at the other side. Yeah, you can see, even on the other side we have burnt copper. So with a layer burn, if you see damage present on both sides, it means you've probably got a hole all the way through your board. The only way to get rid of this 88 ohm short circuit is to cut out all the burnt area and then rebuild it as necessary. Let's just clean up around that small spot there. Clean up around that small spot there. Zoom in a little bit so you can see what I'm doing. Hopefully the camera's picking this up. So yeah, the only way to fix this is to cut out the damaged layer. Hopefully it hasn't severed any traces, but yeah, it goes all the way through. Okay, so I'm going to cut out this layer with a combination of a razor blade and a little grinding pen. And we'll see if we can resolve the short circuit. It's going to be kind of hard with this microscope because when I'm filming, I lose one of my eyepieces, which means I don't have the same depth of field I usually would. It's harder to tell where things are, but we'll see what we can do. Oh, I'm already seeing traces there. That's not good. Just up on this right hand side, I've just cut through a trace there. Maybe not cut through, but I can see it just about. Yeah. So that's just on the edge of the hole, so I'm going to have to cut and rebuild that, I think. Okay, I'm all the way through already. That was quick. Not too many layers in this board. So, start cleaning up the other side. I managed to get through without breaking that trace, which surprised me. Maybe I've got lucky. Oh, there's a trace on this backside. Yeah, okay, so that I need to fix. There's a trace just coming in down here. It's just on the edge of where this hole is, so I need to figure out where that goes, because that's probably important. Yeah, there it is. So it runs just across there and connects back up there. Let's clean up the hole a bit more. Get rid of all that black marking around the edge. Okay, I've got the trace exposed a little bit, so I should just be able to solder a jumper wire between those 2 points where it's broken. The hole is, well, the burn is gone. The hole is not gone. There's definitely a hole there. Stuff like this annoys me. So, I mean, HP have literally made a system that burns a hole in its own board for no reason. I think Razer also produce a 14-inch laptop that does very similar, just by the fan mount. Manufacturers need to start paying a bit more attention to where they put their traces, because this shouldn't happen. This shouldn't be able to kill your laptop. And as I say, I've seen it on Envy X360s about 3 or 4 times now, so this is certainly not the first one that I've seen that's just burnt a hole through itself. So if anyone from HP is listening, this ground trace is too close to this power plane and it causes the hole to burn all the way through the PCB. This should be fixed, and it should be fixed for customers that have had this problem free of charge. There should be a product recall on this, so yeah, do better, I guess. Anyway, let's now the rant's over, let's go back to that cap I measured earlier. It was 87 ohms earlier, so what is it now? Yeah, 0.25 meg, so 250k. Which is good, it means the short's gone. Let's patch up our little trace. And see if it turns on. Use a bit of solder paste and my heat gun to tin up these 2 points. Okay, our jumper wires ran, so now we just put some UV cure over the area, tidy it up a little bit, and we should be good to put the laptop back together and test it. Oh, that's way too much. I'm just going to tidy up all of this area that I've cut into. Now there are some ground layers and some 12-volt layers around here, so this is just going to help isolate those. Make sure they can't short together or dirt can get in and cause anything else to burn. The 12-volt and ground layers are still intact, so I don't need to do any trace repairs to them, which is good. It doesn't really matter that there's a hole running through it, basically. It just means we have a tiny little bit less capacity to deliver the same amount of current, but I don't think a small amount like this is going to change too much, and I've done a couple of these before without any return issues, so it should be all good. Just get that looking nice and good. I'm going to do this in layers. I'm going to start on the back, and then I'm going to do a bit more, and then I'm going to go from the front. Add all this UV cure and just try and get the inside of that hole as well. There'll still probably be a bit of a hole there, but it'll be a lot smaller. There we go. It's all cleaned up with the help of a bit of UV cure. Yeah, let's get this back in the chassis and see if it turns on. And don't forget to plug in the DC jack. The one connector under the board. There you go. I'm feeling confident, so I'm just going to put all the screws back in and assemble it, assuming that I fixed the problem. Okay, I'm gonna get rid of that extra fan mount and get rid of that screw. I don't want any chance of anything rubbing through the board there, so yeah, I'm gonna cut that off. If you've got one of these systems and you're worried about it dying, just take it apart, pop the fan out, and cut that off. Get rid of the screw there completely, and there's no chance it'll die. There's no chance it'll burn a hole in itself, so it's probably not the best thing to do in terms of fan stability, but it's better than burning your motherboard. Okay, I guess this is the moment of truth. Find out if I put all those screws in it just to have to take it apart again. So, plug it in. And turn the supply on. Okay. Okay, it's drawing 160 milliamps. Still got a charge light, which is good. Oh, and it responds to the power button now. Are you gonna work? Charging. Hey, it's on. Nice. CMOS reset. CMOS checksum is invalid. Yeah, that's because the battery's been pulled. Hit enter. See if it boots to Windows. Nice. It's working. Awesome. Well, yeah, there we go. Shut that down. We'll get it tested. We'll make sure everything's all good, and we'll send it back to the customer. So yeah, thank you HP for producing a device not fit for purpose that randomly burns a hole through its own motherboard. Slap that like button if you liked this video, and subscribe if you want to see me slice open more motherboards. Goodbye.